Good morning to everyone. Today we'll learn about 12th standard chemistry. So already we have learnt 5 lessons in chemistry. So I hope you are studying the everyday portion assignment. Okay. So today we'll learn a new concept, that is coordination compounds. Okay. So in this coordination compounds you can able to see the coordinate bond. So a bond formed by transfer of electron is ionic bond. A bond formed by mutual sharing up of electron is covalent bond, you know. Here a bond is formed by sharing of a pair of electron, completely by sharing a pair of electron, or one pair of electron will be donated to other ion and it will form a compound. Okay, the metal ion will donate a pair of electron and it will form a compound. Okay, here ligand will donate a pair of electron to metal ion and forms a compound. Okay, so here that compound, that bond is known as a coordinate bond. Okay, so you can see coordinate bond in coordination compounds. So here the scientist of interest is Alfred Werner. So Alfred Werner is the scientist of interest. Okay, so Alfred Werner in 1913 he got the Nobel Prize. Okay, so Alfred Werner in 1913 he got the Nobel Prize for chemistry for this coordination compounds. Okay, so for giving explanation about the bonding in coordination compounds, types of coordination compounds. Okay, he was given the Nobel Prize in 1913 and he was the only inorganic chemist, or he was the first inorganic chemist, okay, who got the Nobel Prize. Okay, he was the first inorganic chemist who got the Nobel Prize in first inorganic chemist who got the Nobel Prize in 1913. Okay, so he was the scientist of interest in this lesson, and the learning objectives of this lesson is we are going to learn about the coordination compounds, different compounds. Okay, Werner's theory, the limitations of Werner's theory, different types of isomerism and different types of coordination compounds, its properties, its uses, its application in our day-to-day life. So these are the learning objectives in this lesson. Okay, now this coordination compounds, it is obtained from the two words complexes and coordinate. Means in Latin it means hold. Okay, complexes and coordinate, in Latin it means hold and arrange. So complexes meaning hold and coordinate to arrange. So here in coordination complexes, okay, coordination, okay, so coordination complexes, okay, in which it was the Latin word. Okay, so it was a Latin word. So complexes meaning hold and to arrange. So coordinate, okay, so it is a Latin word. So this coordinate meaning to arrange. So here the atoms or ions or groups are arranged, okay, with a metal ion and it forms complexes. Okay, so coordination to arrange. Okay, so these are the meaning for the coordination complexes. Okay, what are the coordination compounds we can able to see in our day-to-day life? For example, here the coordination complexes can formed by most of the metal ion, that is from transition elements. So last lesson we have seen is the transition elements or D block elements. So in that D block elements form most of the coordination compounds. Now in this coordination compounds it will be mostly metals. Okay, metal ion that will form a bond with ligands. Okay, it may be a positive ligand, it may be a negative ligand or neutral ligand. Metal ion vandu ligand oda சேர்ந்து it forms coordination complexes, whereas it may also be non-metals. So it may be ligand or it may also be non-metals. Okay, and for example in chromium 3 chloride, okay, it is a purple compound. Okay, it is an inorganic compound. Okay, so it can form coordination complex with metals and as well as in non-metals, whereas most of the compounds are formed from the transition metals. Okay, so some of the examples we can see in our day-to-day life is hemoglobin. Okay, so hemoglobin, it is very important for the oxygen transport in human beings. Okay, that hemoglobin, it is nothing but a coordination compound of iron or the central metal ion in coordination compound iron. ஸோ ஹீமோக்ளோபின் பார்த்தீங்கன்னா அது வந்து ஆக்சிஜன் டிரான்ஸ்போர்ட்டுக்கு ரொம்ப ரொம்ப முக்கியம். அந்த ஹீமோக்ளோபினில் இருக்க அயன், ஸோ இந்த அயன் வந்து சென்ட்ரல் மெட்டல் அயான் என்னன்னு பார்த்தீங்கன்னா தட் இஸ் அயன். ஓகே, தட் இஸ் அ கோஆர்டினேஷன் காம்பவுண்ட். தென் chlorophyll, it is an important photosensitizer. It is used as a sensitizer in photosynthesis. It is an important pigment. Okay, that is used for the green coloration. In that magnesium, okay, so magnesium is an important atom or ion that is forms a coordination compound. Then our important vitamin, that is a protective vitamin cobalamin, which contains cobalt, or it is a coordination compound of cobalt, or the central metal ion in cobalamin is cobalt. Okay, vitamin B12 cyanocobalamin, it is an important compound, okay, for our hemoglobin as well as for our oxygen transport in the human body, and to prevent from defective or deficiency diseases. This cobalamin vitamin is very very important, in which it is a coordination compound of cobalt. So from all these examples you can see the coordination compounds are useful in our day-to-day life, as well as these coordination compounds are used as catalyst. For example, Wilkinson catalyst, then Ziegler-Natta catalyst. Okay, Wilkinson catalyst, Ziegler-Natta catalyst are important catalysts used in industrial process. So in the Wilkinson catalyst, Ziegler-Natta catalyst la important catalyst எதில் யூஸ் பண்ணுறாங்க அப்படின்னா நம்மளுடைய இண்டஸ்ட்ரியல் ப்ராசஸ், some of the synthesis reactions they are using this as a catalyst. Okay, Wilkinson catalyst and Ziegler-Natta catalyst. Ziegler-Natta catalyst is nothing but titanium tetrachloride and triethyl aluminium. Okay, so that is used as a catalyst in the preparation of polythene. Okay, ஸோ இந்த மாதிரி கேட்டலிஸ்ட் வந்து நிறைய இண்டஸ்ட்ரியல் ப்ராசஸில் வந்து அவங்க நமக்கு யூஸ் பண்ணுறாங்க. ஓகே, ஸோ திஸ் கோஆர்டினேஷன் காம்பவுண்ட் they are used as a catalyst in different chemical reactions. Okay, so these are the introduction about our coordination compounds. Then coordination compounds and double salts. Then we'll see the difference between coordination compound and double salts. Okay, coordination compounds and double salts. So you can see coordination compounds and double salts. Here the coordination compounds, when two or more stable compound mixed together and when it is evaporated, it forms a compound that is known as our coordination compounds, or it may form a double salt. ஒரு ரெண்டு ஸ்டேபிள் காம்பவுண்ட்ஸ் வந்து மிக்ஸ் ஆகும்போது, மிக்ஸ் ஆகி ஒரு சொல்யூஷனில் மிக்ஸ் பண்ணி அதை நம்ம எவாப்ரேட் பண்ணும்போது நமக்கு டபுள் சால்ட் கிடைக்கும், இல்லை கோஆர்டினேஷன் காம்பவுண்ட் கிடைக்கும். ஃபார் எக்ஸாம்பிள், ஃபெரஸ் சல்ஃபேட் அண்ட் அமோனியம் சல்ஃபேட் ஆர் மிக்ஸ்ட், இட் ஃபார்ம்ஸ் மோர் சால்ட். இது ரெண்டையும் மிக்ஸ் பண்ணும்போது நமக்கு என்ன கிடைக்கும்? மோர் சால்ட் கிடைக்கும். ஸோ திஸ் மோர் சால்ட் இஸ் நத்திங் பட் ஃபெரஸ் அமோனியம் சல்ஃபேட், that is FAS. Okay, more salt is nothing but ferrous ammonium sulfate, FAS, that is FeSO4 into NH4 twice into SO4. Okay, so FeSO4 into NH4 twice into SO4. Okay, so we'll get more salt. Okay, this is an example for our double salt. Then in the preparation of our potassium ferrithiocyanate, okay, so K3FeCN6. Okay, potassium ferrithiocyanate, K3FeCN6, potassium ferrithiocyanate, it is an example for coordination compound. Okay, it is prepared. Okay, it is an inorganic compound. Okay, it is in the inorganic qualitative analysis, when you mix ferric chloride and ammonium thiocyanate, you can get this potassium ferrithiocyanate, that is SCN6. Okay, so is formed. So what is the difference between these two? Okay, when you do the inorganic analysis, or when you dissociate, or when you dissolve the two compounds in different solutions or in water, what happens? This will dissociate. Or when you test in the inorganic qualitative analysis, the first compound, in the compound வந்து ammonium, iron 2+, ammonium and sulfur, sulfate ion. Okay, iron 2+, okay, NH4+ and SO4 2-. So in the ions answer பண்ணும். Okay, so and then whereas this compound will not answer for Fe3+ and SCN-. ஸோ இது வந்து K3 FeCN6 SCN6 வந்து ஆன்சர் பண்ணாது. அப்போ என்ன தெரியுது, திஸ் double salt will dissociate in solution or the double salt ionize in solution. The double salt வந்து it will be dissociated into constituent ions or it will be dissociated into simpler ions. ஸோ இந்த ஃபெரஸ் மோர் சால்ட்டை தண்ணியில் கரைக்கும் போது என்ன ஆகும், அது கான்ஸ்டுவெண்ட் அயனாக பிரிஞ்சிடும். ஏன்னா அந்த ஆன்சர் பண்ணுறதை வச்சு நம்ம சொல்லிடலாம். ஃபார் எக்ஸாம்பிள் அயன் 2 + NH4 + SO4 2- ஆன்சர் பண்ணுது, அதை வச்சு நம்ம சொல்லிடலாம். வேறஸ் this will not answer for the different test. இது வந்து ஆன்சர் பண்ணாது. ஸோ இது வந்து ஏன் ஆன்சர் பண்ணாது அப்படின்னு பார்த்தீங்கன்னா, இது வந்து K3 FeCN6க்கு ஆன்சர் பண்ணாது. பிகாஸ் தி coordination complex will not dissociate into simpler ions in solution. So that is the stability of this coordination compounds. Okay, so this is about the coordination compound and double salt. Okay, double salt will dissociate into simpler ion or constituent ion, whereas coordination compounds will not dissociate into simpler ions or constituent ions. Okay, this is about the coordination compounds and double salt. Now Werner, Alfred Werner, he gave a theory on coordination compounds that is known as Werner's theory. Okay, that Werner's theory, he took a compound and he have explained, for example, COCl3 into 6NH3. Okay, so and what are the postulates of this Werner's theory? Today we'll see what are the postulates of Werner's theory. Okay, so this is a very important question. What are the postulates of Werner's theory? So according to Werner, the coordination compounds involves two valence. Okay, here they are using the word valence. Okay, so valence is nothing but the number of electrons in the outermost shell or the combining capacity of an element. So எவ்வளோ எலக்ட்ரான் வந்து outermost shellல இருக்கோ, இல்லை எவ்வளோ எலக்ட்ரான் இன்னொரு ஆட்டத்தோட கம்பைன் ஆக போதோ outermost shellல இருக்கிறது, அந்த நம்பர் தான் என்னது valence. Okay, so here in coordination compound you can see two types of valence, primary valence and secondary valence. Okay, so primary valence and secondary valence. Okay, so here this primary valence correspond to oxidation state of the metal ion. So primary valence வந்து எதை கரஸ்பாண்ட் பண்ணி இருக்குன்னா, it will correspond to oxidation state of the metal ion, whereas secondary valence will correspond to the coordination number of the compound. Okay, so primary valence will correspond to oxidation state of the metal ion and secondary valence will correspond to coordination number. Okay, so this is how they are given. Okay, so in the it will be having two valence, primary valence and secondary valence. Primary valence correspond to oxidation state of the metal ion, secondary valence correspond to the coordination number. For example, in this compound the primary valence is +3. So in the compound la primary valence வந்து +3, that is oxidation state of the metal ion, cobalt உடைய oxidation state வந்து +3, whereas secondary valence coordination number is 6. Okay, the primary valence correspond to oxidation state of the metal ion and the secondary valence correspond to coordination number. Okay, oxidation state, for example in COCl3 into 6NH3, the oxidation state of cobalt வந்து பார்த்தீங்கன்னா +3. அப்போ primary valence எவ்வளவு +3 and the secondary valence is nothing but the coordination number of that compound. What is coordination number? The number of ligand attached to the central metal atom or ion, or it is a donor atom that is attached to the central metal atom or ion. Okay, so here how many ligands attached? 6NH3, so the coordination number is 6. So here in COCl3 into 6NH3, the oxidation state of metal ion is +3 and the coordination number of this ammonia that is a ligand, that is this compound, is 6. Okay, so the primary valence or the primary valency is satisfied by the negative ion. So primary valency வந்து என்ன satisfy பண்ணோம்னா, it will be satisfied by this negative ion, and here this primary valency is satisfied by 6 NH3 molecules. Okay, so primary valency எது satisfy பண்ணது அப்படின்னு பார்த்தீங்கன்னா, it is satisfied by the 6 ammonia molecules. CO3+ was satisfied by 6 ammonia molecule. Then the secondary valency is satisfied by negative ion or neutral molecule or positive ion. okay. So secondary valency negative ion வந்து satisfy பண்ணும், இல்ல neutral molecule or positive ion வந்து satisfy பண்ணும். For example, in COCl3 into 6NH3, the secondary valence is 6, or the secondary valence is satisfied by 6 ammonia molecule. So 6 ammonia molecule வந்து இந்த காம்பவுண்டில் என்ன பண்ணியிருக்கு, இதோட ஜாயின் ஆயிருக்கு. Then in COCl3 into 5NH3, the secondary valence is how much? It is satisfied by 5NH3 and 1 Cl minus, one coordination number 6 இல்லையா, and 1 Cl minus ion. So this is about the secondary valency. Then it consists of the coordination compound, it consists of 2 spheres. So coordination compoundல fourth postulate என்னன்னு பார்த்தீங்கன்னா, it consists of 2 spheres. So அதில் this outer sphere or it is known as ionization sphere, வெளியில் இருக்க இந்த ஸ்பியருக்கு பேர் outer sphere or ionization sphere, and உள்ள இருக்க இந்த ஸ்பியருக்கு பேர் inner sphere or coordination sphere. ஓகே. ஸோ கோஆர்டினேஷன் காம்பவுண்டில் 2 பார்ட்ஸ் இருக்குது. ஒன்று வந்து என்னது அவுட்டர் ஸ்பியர் ஆர் அயனைசேஷன் ஸ்பியர், அண்ட் உள்ளே இருக்கிற இந்த பார்ட் வந்து என்னதுன்னா இட் இஸ் நோன் அஸ் இன்னர் ஸ்பியர் ஆர் கோஆர்டினேஷன் ஸ்பியர். ஓகே. ஸோ ஃபார் எக்ஸாம்பிள் ஹியர் in the inner sphere what happens, the atoms or groups are firmly attached to the central metal atom and it is closer to the central metal atom. So in the inner sphere la pathina coordination sphere la இந்த atoms இந்த groups வந்து இதோட நல்ல firm attach ஆயிருக்கும். அதான் மிஸ் solid lines போட்டிருக்கேன். ஓகே. ஸோ சாலிட் லைன்ஸ் போட்டிருக்க காரணம் என்னென்னா firm attach ஆயிருக்கு, as well as it is closely bound and tightly bound to the central metal atom. ஸோ இந்த central metal atomோட க்ளோஸாக இருக்குது, tightly bound-ஆக இருக்குது. ஓகே. எது that inner sphere or coordination sphere. Then what happens? Then we'll come to the next one. Here the outer sphere, in the sphere pathina it is not thick or it is not hard. That inner sphere is not permanent also. Why? Because the groups attached to this groups present in the inner sphere are ionizable. Ionizable in the sense when you dissolve the compound in solution it will easily dissociate into ions. So இந்த outer sphereல இருக்கிறது வந்து பெர்மனன்ட் கிடையாது. ஸோ அதை நம்ம தண்ணியில் கரைக்கும் போது இல்லை ஒரு அக்வஸ் சொல்யூஷன்லேயோ சால்வெண்ட்லேயோ கரைக்கும் போது வாட் ஹேப்பன்ஸ் அப்படின்னு பார்த்தீங்கன்னா it will dissociate into simpler ions or constituent ions. தண்ணியில் கரைக்கும் போது அந்த லாஸ்ட்டில் இருக்கிற அந்த இன்னும் அவுட்டர் ஸ்பியரில் இருக்கிற அந்த குரூப்ஸ் வந்து எலமெண்ட்ஸ் குரூப்ஸ் வந்து என்ன செய்வாங்க அப்படின்னா they will dissociate into ions, அயான்ஸை பிரிஞ்சிருவாங்க. அதனால தான் அதோட பேர் வந்து என்னென்னா அயனைசேஷன் ஸ்பியர். ஓகே. ஸோ இந்த postulates of Werner's theory we saw primary valence என்னது, it will correspond to oxidation state of the metal ion. Oxidation state of the metal ion பொறுத்து இருக்கிறது primary valency. Then secondary valency it will correspond to coordination number of the compound, and for example the primary valency of that compound cobalt dioxidation state என்ன +3, and secondary valency எதை correspond பண்ணியிருக்குன்னு சொன்னோம், coordination number இல்லை, அப்போ அது வந்து என்னது 6 in that compound. ஓகே. ஸோ primary valency வந்து satisfied by negative ion-ஆல் satisfy ஆகும். ஓகே. ஃபார் எக்ஸாம்பிள் 6 ammonia molecule வந்து அந்த compound satisfy பண்ணுது. whereas the secondary valency அது யாரெல்லாம் satisfy பண்ணுவாங்க, satisfied by negative ion, positive ion, neutral molecules. Okay. So that will satisfy that one. For example in COCl3 into 6NH3, so CO3 plus was satisfied by 6 ammonia molecules, and here CO3 plus was satisfied by 5NH3 and 1 Cl. Okay. So that is our secondary valency. Then in the coordination compound we are having 2 parts, that is the outer sphere or ionization sphere, and the inner one is inner sphere or coordination sphere. In the inner sphere you will have the central metal atom in the center, and to that some of the ligands will be attached. They are firmly attached, tight attached ஆயிருக்கும், and closer to the central metal atom or ion. So it will be tightly bound. Whereas in the outer sphere it is not permanent. It will be dissociated into ions when it is present in solution or when it is dissolved in solution. ஒரு சொல்யூஷனில் கரைக்கும் போது என்ன ஆகும், அது வந்து அயான்ஸாக டிசோஷியேட் ஆகும். எது அயனைசேஷன் ஸ்பியரில் இருக்கிறது. Since it causes ionization, that sphere is known as ionization sphere. So these are the postulates of Werner's theory, and this primary valency is non-directional in nature, whereas secondary valency is directional in nature. Primary valency வந்து non-directional, whereas secondary valency is directional in nature. So primary valency வந்து non-directional, secondary valency வந்து directional in nature. Primary valency is non-directional, secondary valency is directional in nature, and the geometry is explained by the secondary valency. That is how it is explained. The secondary valency correspond to the coordination number. For example, here COCl3 into 6NH3, the coordination number வந்து என்னது இதில் எத்தனை ligands attach ஆயிருக்கோ அதான் coordination number. So here it is 6. So when the coordination number is 6, it will be octahedral. The geometry will be octahedral. So the geometry is explained by the secondary valency. So when the coordination number is 6, the geometry will be octahedral. And when the coordination number is 4, coordination number 4 இருந்துச்சுன்னா it will be tetrahedral. For example, in nickel tetracarbonyl, the coordination number nickel tetracarbonyl பார்த்தீங்கன்னா it is a coordination compound. So அதில் the coordination number வந்து 4, அதனால் அது டெட்ராஹெட்ரலாக இருக்கலாம், இல்லாட்டி ஸ்கொயர் பிளேனராக இருக்கலாம். ஓகே, ஸோ coordination நம்பரை வச்சு we can able to tell whether it is square planar or octahedral or trigonal bipyramidal, okay, or square planar or tetrahedral. ஸோ coordination நம்பரை வச்சு அது வந்து டெட்ராஹெட்ரலா, ஸ்கொயர் பிளேனரா இல்லை ஆக்டாஹெட்ரலா அப்படின்னு சொல்லிடலாம். ஸோ coordination number 6 இருந்தால் that is octahedral, coordination number 4 இருந்தால் அது டெட்ராஹெட்ரலாவோ இல்லை ஸ்கொயர் பிளேனராவோ இருக்கலாம். Okay, now so these are all about the Werner's theory. Then what are the limitations of Werner's theory? Although this Werner's theory can able to explain all the important properties of coordination compounds, it also has some certain limitation. So எல்லா ப்ராப்பர்ட்டிஸையும் முக்கால்வாசி in this coordination theory, that is Werner's theory explain பண்ணிட்டாலும் it has some limitation. What are the limitation? Okay, so it can't able to explain the color and magnetic property of the complexes. So in the complexes உடைய color can't explain the color and magnetic property of coordination complexes. Can't explain color and magnetic property of coordination complexes. Can't explain the color and magnetic property of properties of coordination complexes. So this Werner's theory, although it can explain important properties of this coordination compounds, it can't able to explain the color and magnetic property of coordination complexes. Color and magnetic property of coordination complexes can't able to explain the color and magnetic properties of coordination complexes. Okay, so these are all the important properties of these coordination compounds, or these are all the important postulates of Werner's theory. Okay, so this is a very very important question. So Werner's theory is also very very important one. Alfred Werner, he is a scientist of interest in this lesson. He was awarded the Nobel Prize in 1913. He is the first inorganic chemist to be awarded the Nobel Prize. So அவர் தான் வந்து முத inorganic chemist வந்து this Nobel Prize வாங்கினார் அது. Okay, so these are all the postulates of our coordination compounds. This lesson is also very very important. So in this lesson we'll learn about this isomers, coordination compounds, their properties, their uses, Werner's theory, and the different types of isomerism, the application of coordination compounds. Okay, so for your assignment, today's assignment, you learn the postulates of Werner's theory. Okay, learn and write the postulates of Werner's theory. So your assignment is learn and write the postulates of Werner's theory. So assignment is learn and write the postulates of Werner's theory. Learn and write the postulates of Werner's theory. Draw this diagram also. Okay, postulates of Werner's theory. Learn and write the postulates of Werner's theory. You draw this diagram also. Learn and write the postulates of Werner's theory. You draw this diagram also. Okay, learn and write the postulates of Werner's theory and draw the diagram also. Okay, so this topic are very very important for your exam sense as well as for our topic. Okay, so postulates of Werner's theory வந்து ஒரு டீட்டெயில் கொஸ்டின் இதில் நீங்கள் படித்து அதை வந்து நீங்கள் இது பண்ணிடுங்க, எழுதிருங்க. அப்புறம் இங்கே இந்த காம்ப்ளெக்ஸ் பார்த்தோம் இல்லையா, COCl3 into 6NH3. ஸோ அதனுடைய கலர் வந்து எல்லோ. ஸோ when it reacts with 1 mole of Ag+, that is excess Ag+, அதோடைய number of AgCl used வந்து பார்த்தீங்கன்னா 3, and COCl3 into 5NH3 purple, and the number of AgCl, okay, that is precipitated பார்த்தீங்கன்னா 2, and then COCl3 into 4NH3 la and the compound ude color green, and the number of HCl that was precipitated வந்து 1. Then COCl3 into 4NH3 it will also exhibit violet color, and the number of HCl precipitated பார்த்தீங்கன்னா 1. So இந்த compound தான் அதோடைய, அதை வச்சு தான் we have explained the postulates of Werner's theory. So this lesson is very very important. So with this lesson we'll complete this first volume. Okay, so இது வந்து ரொம்ப ரொம்ப important. So the postulates of Werner's theory வந்து தயவு செய்து படிச்சிருங்க. Okay, so and again and again I am saying, in chemistry you learn and write without writing or without learning or without writing you must not learn this chemistry. Okay, so you have to learn and write. எழுதி பார்த்தா தான் கொஞ்சமாக ஞாபகம் வரும். எழுதலைன்னா இன்றைக்கி நீங்கள் பார்த்த இந்த இதுவே வந்து நாளைக்கு புக்கை திறக்கும்போது ஃப்ரெஞ்ச் அண்ட் லாட்டின் மாதிரி உங்களுக்கு தெரியும். ஓகே, ஸோ அதனால் என்ன பண்ணுங்கள், அன்னன்னைக்கு நடத்துகிறது அன்னன்னைக்கு அப்லோட் வீடியோஸை யூ ரைட் ஆன் த டே இட் செல்ஃப். ஓகே, டோன்ட் போஸ்ட்போன் தி வீடியோஸ், டோன்ட் ஸ்கிப் தி ஆன்லைன் கிளாஸ். யூ கேன் ஆஸ்க் doubts in our online class. Okay, I'm always there to check your assignment and to clarify your doubts. Okay, without any hesitation you can ask the doubts. Okay, if you are not clear in the video or if you are not clear in the online class, you can call me personally and you can ask the doubt. Okay, so this is all about our coordination compounds, its importance, okay, and the postulates of Werner's theory. So I hope you have understood the today's concept. Okay, thank you for listening to me. Thank you.